Today we'll be looking at experiment with the bifilar suspension. And then the main aim of this experiment is to determine the moment of inertia, right? And then also we have to find the relationship between the thread and then the period, right? The thread. So this distance, the distance from here to here is the L, right? That's L, the length. So determine the relation between the period T and the length. Also, we will determine the relation between the period T and the distance. The distance is from this, where the loop is, to this. So that's what we're doing. So the title of our experiment is supposed to be determination of the moment of inertia using the bifilar suspension. Okay, so let's look at the setup. This is a meter rule. This is an extra meter rule to measure this distance. An extra meter rule to measure this, the distance from here to here. And then that one is supposed to be at 60. We fix that one at 60. It remains constant. We don't move it. Okay, that one remains constant. From this to this is supposed to be 60 centimeters. The same thing here, 60 centimeters. And then we need to adjust the thread, right? We adjust this thread so that it becomes vertical. So we can use the rod, right, the stand, as a reference and then adjust it. We make sure the thread is as vertical as possible to avoid error. Okay, so this is how you start the experiment. Now, from the center point, from the center, the 50 centimeters mark, from the center, you hold the center like this and twist it. So this is the oscillation. Okay, then we'll start counting. There's 1, 2, 3, 4, 5, in that order. 20 oscillations with our stopwatch. So we'll measure 20 oscillations and then we record. So we do it twice. That will have T1 and T2. So we'll do it 2 times and then we get T1 and T2. Then we reduce the length. We reduce the length by 2 centimeters. So we increase this to 2. We increase this side to 2, right? We increase this side 2 and increase this to 2 and then count 20 oscillations again. So T1, we oscillate from the middle this way slightly. The angle of oscillation shouldn't be so big. So 20 centimeters, 20 oscillations, okay, for T1 and then another 20 for T2. Then we further increase this and then this side too as well by another 2. And then once we move the loop, we have to make sure that the thread is vertical. So we can shift this and then make the thread vertical. We check the other side as well. Once we move this, we make sure we make the thread vertical before we oscillate and take our time. So for each movement, we make sure the threads are vertical. And then the meter rule also very horizontal. Okay, so that's that. So this is how the table will look like. This is how the table will look like. Now we have D, which is the distance from this point to this point, and then our T1 and T2, and then we'll find the average, and then we divide the average by the number of oscillations to get the period, and then also the log of T and then log of D. The log of T and log of D. Okay. Then after that, we'll be plotting this against this. We plot log D against log T. So this is the equation that was given in the book. This is the equation for the bifilar suspension. So since we are supposed to log or plot a log of it, we need to apply log to this equation. We apply log to this equation. So we square it first to remove the bracket. We square it first to remove the bracket, the square root. We square both sides to remove the square root, and then we apply log to it. When we apply log to it, we come and get an expression like this. Now, since we are plotting this against this, we can arrange this to come here. So this becomes positive, and this goes here. This becomes negative. So it means that our y component give us log d. Our m is supposed to give us -1, because when we bring this, these are s component. When it crosses, there is negative in front, so that's -1. And then our x is the log t. It means the whole of this expression is our intercept. And then after finding the slope, so we find the slope. After finding the slope, we can negate the slope, because the value of the slope is supposed to be negative. So you get a positive slope, but you negate it. And then also, to find the moment of inertia I in this expression, the value of the intercept here, we said that c, which is the intercept, this whole thing is this. So we equate this value here, the value of this, to the whole of this expression. Then we have this as a constant, this as a constant, pi as a constant. The mass is the mass of the meter rule, is behind it. The mass of the meter rule. The mass is the mass of the meter rule. So the mass of the meter rule is behind it. That's the m. Our g is our gravity. Our L is the length. The L is the distance from here to here. The length is in the book as 60. Then we can make I the subject, moment of inertia the subject, and then find I. Thank you very much.